Something you know, and something you have, is a security model that's been around for quite some time for OpenSSH. It's a lot more secure than using just usernames and passwords. But how do you actually configure SSH keys on a Linux computer, for example? Well, if that's something you're interested in learning, then stick around and watch this video, because that's what we'll be going over. Now, I will be putting a timeline into this video, so by all means skip ahead if you want to just know how to actually configure and deploy SSH keys. Now, I want to give a bit of a background as to how these actual SSH keys work and why does we want to use them in the first place. So if you think of your typical login process for this server, for instance, it's a Linux server, and we'd start an SSH session from our management computer over to this server. We'll have to put in our username and password. The server will authenticate that against its local database. And then, assuming we've passed the actual test, we'll be able to gain access to the computer. But the only thing that's involved here is something you know, and we want to introduce extra security here. We want something you know and something you have. And that's where the SSH keys come into play. So for that reason, we'll actually create a key pair on this computer using OpenSSH. And we'll actually end up with a public key and a private key. Now the private key stays on that actual computer. We'll copy the public key across to the server and we'll authorize the use of that actual key for authentication for that user. So it means that going forward, that user don't actually have to supply a username and password anymore. They just need to be in possession of the key and a passphrase for that actual key. Because that's what we're also going to be doing is when we create the key pair, we'll be prompted for a passphrase, and we do actually want to create one. It needs to be long, it needs to be complicated, and we don't want it actually to match whatever the username and password pair was for the actual computer over here, because a database is a lot weaker when it comes to security than, say, an actual SSH key. So for that reason, we don't want this weak link within the database, because if somebody gets access to the database or the contents, the passwords, kind of like renders that key pointless. So we want a separate passphrase created for the actual key itself, specifically for the private key. And then what it'll mean is when we run an SSH session to that computer, we'll be prompted for the actual passphrase. Assuming we actually get validated, we'll end up with an SSH session starting to this actual server. And the authentication process will change now because we won't be getting any checks against the local user database. Instead, what will happen is the actual DHCP server it'll generate some random data. It'll encrypt that data using the user's public key, and then it'll challenge the computer over here to actually decrypt it. Now, you can actually encrypt data using the public key, but only the actual private key can be used to decrypt it, and that's where something you have comes into play. So by having a passphrase and an actual private key, you have to know something and you actually have to have something in order to be able to gain access to this server. Now, one thing to bear in mind though is out of the box, that's not entirely true because we do actually have to configure the server to then restrict access so that it doesn't allow authentication through usernames and passwords anymore, for example. So it's a relatively straightforward process to set up. You've just got to be aware that although the actual key is referenced as a public key, from an administrator's perspective, you want to be very careful about what public keys you authorize on your server because you're allowing anybody with that corresponding private key access to your server. So obviously, if somebody leaves the company, gets promoted, or for whatever reason doesn't need access to that server, you'll want to remove that key, probably remove the user account along with it. When it comes to a user's perspective, the private key is extremely important. You don't want to just rely on the fact that it's got an actual passphrase against it. You might want to go as far as encrypting the hard drive, etc., to make sure that it's very, very difficult for anybody to get their hands on that private key. The only thing to bear in mind is, likewise, you want to make sure that that private key is backed up somewhere in a safe place, because otherwise, if you lose that private key, you won't be able to get access to the server. And the way this is all going to get set up once I've done that, for example, is all these servers will get then locked down to certificate access, or rather SSH key access only, meaning I'm going to be fully reliant on whatever key that I set up for that computer. So it's a pretty straightforward process to begin with. We'll just create our key pair on there, we'll authorize it on that computer, and then we'll make some changes on the server, but only after actually testing it. So I'm logged into our management computer because this is where we're going to be doing our SSH sessions from. So the first thing I actually want to do is to switch to what is actually a hidden folder, because this is where we're going to be typically storing things like keys. So it's .ssh. So this is a folder that all users are going to end up with when you're dealing with SSH. I mean, if we have a look at what's already there, for example, we've got a file called known_hosts, and this just basically keeps a record of all the fingerprints of servers that we've logged into, because every time you run an SSH session to a new computer, it actually throws up a prompt asking you to validate the fingerprint is correct. In other words, to validate the actual server you're connecting to is the legitimate server you think it is. If it is, it then starts storing it in this known hosts file, and then it's basically just cycling through, keeping backup copies as it goes along. So that's why we've got these 3 versions there. But in our case, what we're interested in is actually creating our key pair. So I'm just going to copy this line that I've already created. So the command is ssh-keygen. Now, you don't necessarily have to tell it the type. The default type is the RSA algorithm. So if you want to still keep using that, it's still a strong algorithm. You're perfectly entitled to keep using that. I'm just using what is a newer algorithm. It uses less bits when it comes to actually creating these keys. They're still supposed to be very, very strong. So I'm quite comfortable using that. So for that reason, I've had to specify type as -t and tell it to use ED25519. You don't have to put in the -f parameter. All this is doing is it's actually telling it the name of the file that I'm going to use. So, for example, we might have a test environment and a production environment, and we might want to have different keys. Bear in mind, these keys are specific to me, or at least in this particular case, this user account I'm logged in as. But you can have multiple keys, to connect to different systems, for example. In my case, I'm just going to reference this as my test key, for example. Then I've also got a -c parameter added in here, which is to add a comment. So this will put a comment into the actual public key. So it's just to give something extra reference for the actual administrator, for example. So I've called it David_test at templab.lan because that's my domain and my actual temporary lab. It's templab.lan. I'm just referencing that as being my test key. So I'll hit return, and it's now asking what the actual passphrase is. So I highly recommend you use something long, something complex, something out of a password manager, for example. Do use something that's different to the actual password that you use for the user account, because the database could be the weakest link. If somebody gains access to the database, manages to crack it, find out passwords, whatever, it would render this whole process pretty pointless then once they get access to the key. This is making sure that it's a lot harder, because the actual key itself is a lot more difficult to break. So now in my case, I'm going to throw that whole recommendation out the window because it's a video, and I'm just going to end up with no end of problems about putting even a simple password seems to be complicated for me at times. But yeah, there it is. Just mistyped it already. But I need to enter that passphrase again, and that creates it. Now you'll see up here it says it's created a test key -pub, but we've also got a test -key. We've got a fingerprint, some random art, for example. So if I do a look into the directory, you can see we've now got two files. One's called test-key and one's called test-key.pub. Test-key, in my case, is the actual private key. This is something I need to keep a tight rein on. I don't want this leaking out anywhere. It does have a password. Now, in my case, it is a weak password, which I would never recommend. I'm just doing it for the sake of this video. Otherwise, yeah, I'm going to make too many mistakes and it would just take too long to fix. So in this case, I've also got a file called test-key.pub. This is the public key that we need to actually distribute to our actual management, to any computer that we want to manage. Once we've actually got that sent across and it's actually set up to be actually authorized, it means I'll actually be able to use this actual key pair going forward, and I won't have to be able to, have to put in a user account and password anymore. But again, just to re-emphasize, that key there is the private key. That one there is the public key. I mean, I can show you what the public key looks like. So if I type in pub, there's not a great deal to it because that's the actual key that we've effectively got. You can tell you at the start, what type of algorithm we're using. At the end, we've got a comment. And this is a pretty small key because of the fact we're using this particular algorithm. Now, creating a key pair on this management computer here is only one part of the process. The next thing we have to do is to actually deploy the public key to our server and get the server to authorize the use of that actual key. Now, there is fortunately a command we can use, particularly at the start of this process where we've still got access to the server using a username and password. That makes the whole process a lot easier. It means we can do the whole thing in one line. So I'm just going to paste this line in. And what we're doing is we're taking advantage of this command called ssh-copy-id. Now, in this particular case, I've only got one actual key that I can use, but I'm still going to reference it. So I've put in the -i parameter here, and I've told it we want to use the test-key. Now, this doesn't necessarily mean the test key private key that we've got, which is one way to confuse things, I must admit. It's just that's the identification. There's a test key file and there's a test key pub. This is also the identification for the actual key pair itself. So yeah, it can be a bit confusing if you think it's going to copy across the private key, but it's not. I don't have to necessarily put that in, for example. I can just reference it by its identification. Now, the next thing we need to do is to actually tell it, what computer we're going to connect to and which user we're going to log in as. So in my case, I'm logging in as with my account to 172.16.17.12. I'll just double check because that should be the DHCP1 server, 172.16.17.12. Yep, that's the one we want. So I'll hit return. So it's copied across. So it's saying there, it's taking test-key.pub. So again, even though I only put test-key, it's been clever enough to realize we actually want the public key sending across. So it is sending that across. So it's sending across, it's attempting to log in, to add that in. One key needs to be installed, and now it's in, we want the password. So it wants my password. So bear in mind, I'm actually logging into the actual server using my username and my password, not the actual SSH keys. We're not at that process yet. At this stage, all we're at is actually getting the actual public key deployed and authorized. So I've still got to put my my own user account password in here first. I'll hit return. And there we go. So it's added across. Now, it's now actually coming back and say, you can actually test this now if you want to. So if I actually then just do SSH and put in the details that it says, so that's basically how I would have done it anyway, to be fair. Now, in this case, because I'm on an actual Linux Mint computer, it's actually going to cache this passphrase, but it depends on where we go from here, but we can actually cache this passphrase for the duration of my session on this computer, not the session of the terminal itself, but the entire session that I'm logged in. And this will make your life a bit easier. Another option is to tick the box to say automatically unlock this whenever I'm logged in. That to me is a bit of a security no-no because it defeats the purpose of something you know. I don't want somebody being able to log into this computer and to be able to actually take advantage of that key all the time. The whole purpose of that key and passphrase is that if somebody gets a hold of this computer and logs into it or has somehow compromised it while I am logged in, they don't necessarily know what the passphrase is. They might be able to get access to my user account and password, but not the passphrase of the computer unless I've used that. So for that reason, I would never really want to tick that box, but I still have to actually put in the actual passphrase. And that's what it's prompting there. It says enter the password to unlock the private key. It's not asking for my user account password, but the passphrase of the private key. So I've put that in, click on unlock. and it's now logged us into the computer. So what it's actually done is, we're in our home folder. If I do ls-l, not seeing anything in there, what it's actually done is it's created a folder called .ssh. Now, this folder did not exist until now. You can see it's actually created it today. If I go to .ssh and have a look in the folder, it's actually created a file called authorized_keys, because this is how it works. It hasn't just simply copied the file across as is. It's created a folder in my home directory called .ssh. It's then created an actual file called authorized_keys, but that actual file happens to be the same as our public key. So if I actually do more authorized keys, you'll see this is actually the same contents as our public key, because that's all it's done. As I say, it's created the folder, it's created the file, and it's put the contents of our public key, because the idea is you can have multiple keys. That's why it's referenced as authorized keys, emphasizing the plural there. You can have multiple keys within this account, and what you'll end up doing is just adding more of these public keys into this file going forward, and then the server will be able to test against the different keys that you've got for authentication purposes. So that key, that command that we've used has made life a bit easier, if you will. It's done all of that in one process. So it's created a folder, it's copied the file across, albeit it's created it in a new file. You could have done the whole process manually. That was just an easier way. The only thing to bear in mind, though, is we can still gain access to this computer through password authentication, for example. And likewise, I mean, if I exit out of this terminal and just say yes, I'll start up another terminal session, SSH, so 172.16, 172.16.17.12. Notice it didn't prompt me for anything. And the reason being is when we first did it, it actually cached it. It cached that passphrase for this private key, but it's only cached for the duration of my login. So if I log back out again, I'll just close that terminal. So I'll just tell it to log out. Because what I'm going to do is then I'll log back in just to demonstrate the fact that it's going to ask me to provide that passphrase again, and that to me is the better option. From a security perspective, I think that makes life a lot better. So I'll just close that. So if we do that again, there again, now it wants the actual passphrase for the private key. It does say password, but private key, so it can be a bit confusing, I must admit, in the sense that it's when you actually create the key pair, it's referring to a passphrase. When you're actually caching it like this, it's asking for a password. Interesting enough, it does reference, the comment that we put in there anyway. But again, that makes life a bit easier. So like while you're actually logged in and for the duration of this process, I mean, I can keep logging into that computer without having to keep putting the passphrase in. So it does make life a bit easier, if you're going to be getting access to it for quite a few times over the space of a day, for example. But it's another reason why you should always log out of a computer once you've actually finished with it. Now, the only thing to bear in mind is that at this stage, it is still possible to log into that server using an actual user account and password, even though this user on this computer at least has got an actual private key and a public key to authenticate against. That username and password could be used on any other computer potentially. I mean, we do have restrictions in place, but it could potentially be used to log in, to that computer just using a name and password, which we don't want. But the whole purpose of this is to make the whole process a lot more difficult. We want to force the use of SSH keys going forward. So for that reason, we actually need to reconfigure the actual server itself so that it only accepts SSH keys going forward. Now, although we've created an SSH key pair on our management computer, and although the DHCP server has been configured to authorize the use of that key pair, the problem that we've got is that if you try to gain access to the DHCP server from any other computer, it's still going to go through this process of allowing password authentication. In other words, you can still supply a user account and password to gain access to it. So, for example, what I've done is I've disabled the personal firewall on the DHCP server, and I'm on the DNS server. If I try to log into this server now using my user account, you can see it's prompting me for the password for that user account. So there you go, it's allowed us in. So although we've introduced these SSH keys, they're only of any relevance to the management computer. And the whole idea is we want to enforce this security model of something you have and something you know. And as long as the server's accepting password authentication, well, that's not going to happen. So we've still got a weak link here and we need to shut it down. So what I'm going to do is I'm just going to back up the configuration file for the SSH service. So I'm just going to run this command. So it's copying this file to another file as a backup. So the configuration for SSH is stored in /etc/ssh, and the configuration file itself is sshd_config. So hit return, and then what I want to do is actually edit that configuration file, because there's only one line we want to change. There's a lot of things you can change in this config file, but the one I'm interested in is if we scroll down here, there's a line. I mean, I could search for it to make life easier, but I don't know why. When it comes to these Ubuntu servers, we've got a line in here which is commented out, which is password authentication, yes. So basically what it's doing is it's allowing authentication using a username and password. If you scroll right to the bottom, there's an active line which is the same. So I think it's a bit confusing, I must admit, because I saw that the first time and I thought, well, surely that's commented out, but it's not. It is commented out, but lower down it's active. So yeah, I don't know what the devs are up to, but c'est la vie. So I'm changing this from yes to no, which means I do not want to allow password authentication on this actual server. If I scroll back up, there is one other thing I wanted to point out, and that's just to do with root login. Because by default, Ubuntu does not allow root login. You can see there's a line here saying permit root login, prohibit password. So if I uncomment that line, what that would mean is that if I've got a private key and the public key is on this server and authorized, as long as this line's active, it means you can log in as the root using SSH keys. At the moment it's disabled and it means you can't do that. Another thing you want to look out for is if you do see this other line, I'll find it. This one here is the password equivalent. So if you see that line, permit root login, yes, it means you can actually log in as the root using the root account and password. But by default, fortunately, with an Ubuntu server, you can't do that, at least with this particular version, 20.04. Anyway, we've made our change. We've disabled password authentication. So we'll save that, but I've got to restart the actual service for it to take effect. So we just go to restart that, just copying the line just to make my life a bit easier. And then I'm just going to double check that that hasn't broken anything. Okay, so that's working. So if we go over to our DNS server, if I try to log in now, you can see it's coming back with a denied message saying permission denied, public key. So what that basically means is that you cannot get access to this server anymore unless you've got a private key and the actual public key that goes with it has been authorized on the actual server. So that's something to bear in mind now, is that because I've locked the actual server itself down, if I created a user account, a new user account on this server, the actual user can't create a private key and a public key and upload their own public key anymore. It's a bit of a paradox here in the sense that even though the account might exist on the server, you can't get access without the actual key being authorized, and the user themselves can't get remote access with the public without that public key uploaded and authenticated. So that's just something to bear in mind. I mean, we could do it because the system was open. It was allowing access through a password authentication. So we could log in and upload our actual public key using the SSH copy ID command, because we can, authenticate using the password authentication process. But now that's blocked. So what it means is really only an administrator or somebody who's got access to the server with the SSH keys can do that sort of thing going forward, which, to be fair, is something you would be doing anyway. The expectation is an administrator would be creating a user account and along with a private key and public key for that user, but then give the user their private key and their password and so on to be able to then get remote access to the server. But that's just something to bear in mind, as we've now tightened the security up, because now, well, we're actually using these SSH keys, and you just cannot get access unless you've got that actual private key, and in our case, unless you know the actual passphrase that goes with it as well. So we've now actually enforced it so that authentication requires something you know and something you have. Now, the one last thing I want to cover is just multiple keys as well as the config file. Because in a typical computer environment, you're probably going to have a production environment and a test environment. Each will have their own separate user accounts, or at least they should. The idea is that you log into the production servers using one account, you log into your test servers using a completely different account. If one gets compromised, it doesn't impact the other. Test environments tend to be less stringent in terms of what their requirements are versus production. And it's also useful to make sure that you've got different accounts, because then you're less likely to accidentally end up in the production environment and start, making dev changes for testing purposes and so on. But anyway, in my example here, I've got two keys. I've got a prod key and a test key. So the test key has actually been assigned to the DHCP server, whereas prod key has been assigned to my actual domain name server, DNS server. It's just for an example purposes, the fact that I've got two separate keys. So the idea here is I need to be able to log into different servers using different keys. Now, out of the box, I don't really need to do anything because the actual system's going to work on its own. If I actually try to SSH to say, well, I don't necessarily have to put my user account in. I'm logged in as David. I mean, if I was logging in as a different user account, I would have to put that in, but I'm just doing it for reference purposes only. So if I do an SSH session to the DHCP server, you can see you logged in, okay. If I put in -v for verbose, you'll see actually if you scroll a bit further up, it actually tried to connect using several different keys. Ultimately, the server accepted the test key, but the actual computer, this management computer, tried to gain access to the DHCP server using every known key that it has. And we come back out of there. If I do the same with the DNS server that we've got, you'll see that goes through the exact same process, except it eventually settled on the production key that we've got. So that's something to bear in mind, is that it can cope on its own. So it's got, at the moment, we've only got about 2 keys plus a series of built-in keys, so it's not much of a deal. It certainly doesn't introduce any noticeable latency, for example. But there is a certain limit as to how far it can go. I mean, I don't think I've been in a situation where I've needed that many keys anyway. Usually you only need about a few, but in this particular case, what you can do is you can actually take advantage of the config file to try to simplify this whole thing. And what we're going to do is we're actually going to create the file first, because this is a file that SSH is going to refer to. By default, it doesn't exist, so I'm having to create it. The only reason I'm just creating an empty file is just so I remember to change the permissions on it. So if I do ls-l, you can see now I'm the only one with read-write access to it. And then what I'm going to do is edit that. Now I'm going to copy in an example of a configuration. Entirely up to you what you want to do. Different ways of doing this, but what I've got here, for example, in my first line is host star or asterisk. What that means is all hosts. So it means any of these parameters that are just below all reference every computer. So it doesn't matter which computer we try to log into, we want to use this parameter identities only, and we want to set that to yes. What that actually means is that when it logs in, we only want it to use the identity that we tell it to use. In other words, don't go through every single possible public key we've arranged to get authorized, every known private key that we've got our system, so on. Only use the one that we're referencing. And you'll probably notice lower down, we've actually got some references to specific keys we want to use. So that's what that command's specifically for. It basically saves it working its way through every single key on the system. Now, what we've then got lower down is entries for 2 individual computers. So you'd have to put in settings that are specific to individual computers, for example. In our case, we've only got 2. What you actually name these is entirely up to you, but this is going to be what you'll reference with the SSH command. So in my case, I've just gone with a host name. So if I type in SSH DHCP1, for example, these 3 lines apply, plus that line up there. On the other hand, if I type in SSH NS1, these 3 lines here apply, plus that line up the top. So it's a case of what we've set up is just an example here. So in the case of DHCP1, I've referenced it by its IP address. In the case of NS1, I'm referencing it by the actual DNS name. And if we go by the user account, well, in this case, they're both the same, but I could use different user accounts for different systems. Again, if it was prod and test, it would certainly make sense to have different user accounts for each. That way the actual the developer, for example, can even distinguish between the 2 as well. But the key difference is the identity file itself. So here I'm referencing exactly which key we want to use when we log into this computer. So I'm telling it when it logs into the DHCP1 computer, we want to use the test key. Whereas when we log into the NS1 computer, we want to use the prod key. Now, one thing you might notice is the fact that that one's in quotes, that one's not. All I wanted to just demonstrate is the fact that you can use quotes, and it makes sense if you've got spaces anywhere in here for file names and so on. In this particular case, we're not, so as we demonstrate here, you don't actually need them. So I'm just going to save that configuration file. So now if we try to log into the DHCP server, so I'm just typing SSH DHCP1. Now, to be fair, I could do that anyway, because I'm logged in as David anyway. The only thing is config file is also referencing the actual the key that we want to reference as well. I could put that actual key into the command line here if I wanted to, but I've just simplified the whole process by bundling everything into the actual config file. But one thing I will point out is this particular version of Linux that I'm using, it won't work with just host names. They've disabled part of the DNS resolution on host name only. It relies on anycast DNS or multicast DNS to be able to resolve host names. It won't go to the DNS server anymore. It's fully reliant on multicast to be able to do that. I could change it, but I haven't. But in this case, with me having that config file, I can just reference it. Well, I could reference it exactly how I want it to. It really depends on that reference for the host entry that I've put into the config file. Anyhow, by putting in SSH DHCP1, I'll just put -v for boss. Again, it'll just log in. Now, the only clear difference you might notice this time is the fact that we haven't referenced anything except the test key. And that's because of that setting that we've got, which is identities only. I don't want it to try every single key that it knows of. I only want it to use that one key, and that's exactly what it's doing. So in that config file, it's basically telling it what user account to log in, where to log in, which key to use, and only use that key. So it makes the whole process a bit easier, I must have it. I mean, obviously, if you're going to end up with like tons and tons of servers, there should be some commonality there. It's like for production servers, they'll want to use a certain production key. Test servers want to use a test key. You'll want to use a certain account, so you can reference it based on the config file in some way, based on the wildcards and so on. But in this case, it's just a basic example, and as you can see, all we've used is the prod key. So it does make life a bit easier, I must admit, having that config file, and it's just specific to this computer. Bear in mind, it has no relevance to the actual servers themselves. It's just making it easier for this actual SSH client that we've got. But yeah, something useful to know if you're going to be using SSH keys, and I do recommend them because they definitely improve the security significantly on your network. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.